Hi and welcome to the video training of Elixir. In today's video training we will be learning about typespecs and behaviors. Elixir is a dynamically typed language, so all types in Elixir are checked at runtime. Nonetheless, Elixir comes with typespecs, which are a notation used for declaring typed function signatures, also called specifications, and declaring custom types. Let's look at function specifications. Elixir provides many built-in types such as integer or PID that can be used to document function signatures. For example, the round function, which rounds a number to its nearest integer. As you can see in its documentation, round typed signature is written as round and you pass in the number, colon, integer. The syntax is to put the function and its input on the left side of the resolution operator and the return values type on the right side. Be aware that types may omit parentheses. In code, function specs are written with the @spec attribute, typically placed immediately before the function definition. Specs can describe both public and private functions. The function name and the number of arguments used in the spec attribute must match the function it describes. Elixir supports compound types as well. For example, a list of integers has type integer or maps that define keys and types. Defining custom types. Defining custom types can help communicate the intention of your code and increase its readability. Custom types can be defined with modules via the @type attribute. A simple example of a custom type implementation is to provide a more descriptive alias of an existing type. For example, defining year as a type makes your function specs more descriptive than if they had simply used integer. Let's look at this program. It's a module and the module is called person. So let's define this. Let's first enter the interactive mode of Elixir and let's define the module person do, and let's add some documentation. Type doc, a 4-digit year, for example 1984, and close the documentation. And let's define a type year integer. Now let's define spec current age year colon integer. Let's define a variable current age year of birth. Do hash implementation. We got an error. It says unexpected reserved word do, in case you wanted to write a do. Okay, I mistyped it. It was basically do and colon are together. There is no space in between. So do colon. Okay, I missed the colon here. Okay, I think we need to redo and type the whole thing again, but let's see if I end it. No. Okay, left module person, then we have @type doc, a 4-digit, end of documentation, type year integer, spec current year integer, current year, current age year of birth, do implementation. Okay, and end. Says syntax error because before end reserved word in Elixir and therefore it is used as limited function. It can be used as a variable or defined nor invoked as real function. The type doc attribute, similar to the doc and module doc attributes, is used to document custom types. You may define compound custom types, for example maps, type error, map, resolution operator, percentage, and you can pass in message, string.t, and line number, that is integer. Let's look at another example to understand how to define more complex types. Say we have a lousy calculator module which performs the usual arithmetic operations, sum, product, and so on, but instead of returning numbers, it returns tuples with the result of an operation as the first element and a random remark as the second element. Okay, let's define a module called lousy calculator. Def module lousy calculator, do the rate spec, add number comma number, resolution operator, and here you pass in number and string.t. Now let's add function, define a function, add x comma y, do x plus y, you need a calculator to do that. That's a string we will be passing, and then we have the spec multiply function, multiply spec number comma number, and the params it will accept is number and string t. We define the function def multiply x comma y, do x multiply by y, g's come on, and let's end the module. Okay, we have the module now that is called lousy calculator. Tuples are a compound type and each tuple is defined by the types inside it, in this case a number and a string. To understand why string.t is not written as string, have another look at the Typespecs doc. Okay, if I say lousy calculator dot add and pass in two numbers, I got 6. And let's run the multiplication function, 5 and 10, we got 50. Okay, defining function specs this way works, but we end up repeating the type number string.t over and over. We can use the @type attribute to declare our own custom type and cut down on the repetition. So this code can be refactored using a custom type attribute. So here you can see we have number with remark and we are declaring number comma string, and we are using this variable or type attribute number with remark in our two of the specs, the add specs and the multiply specs. So let's rewrite our module, def module lousy calculator do, and this time let's just skip the documentation. We don't need the documentation, so I'm skipping this part. Type number with rank and number string.t. Okay, now we will be using this type attribute in our remaining code. Here I'm going to use it number with rank. Sorry, number, okay, it's number with rank. It's basically number with mark. I mistyped it into rank, doesn't matter. Okay, so let's add the comma y, do colon x plus y, and just type sum. Okay, now let's define the multiply spec. Multiply number resolution operator number with rank. Okay, define multiply and x comma y, do x multiply by y because we are going to do multiplication this time, and we can pass multiply as a string. Okay, forgot to add the colon here, the multiply line. So okay, let's do it again. Okay, no problem, it won't take much time. Rank spec add number def add spec multiply and def multiply. Here I made a mistake, I forgot to add colon here. Okay, now it's fine. Let's press enter. So we have a new version of lousy calculator. So if I run this again, lousy calculator dot add 100 and let's say 80, I got 180, and if I call the multiply function, I got 8000. So custom types defined through @type are exported and are always available outside the module they are defined in. Similarly, you can see here we have def module quite calculator do, and in this module we are defining a spec add, and then we are defining the function add, which is using the lousy calculator add function right here in the add function. Similarly, in the make quite spec, it is again using the number with rank variable from the upper code. So if you want to keep a custom type private, you can use the @type p attribute instead of type. So you just add p in front of type and you make the custom type private. The visibility also affects whether or not documentation will be generated by tools like Xdoc, Elixir's documentation generator. Static code analysis. Type specs are not only useful to developers as additional documentation. The Erlang tool Elixir, for example, uses type specs in order to perform static analysis of code. That's why in the quiet calculator example, we wrote a spec for the make quiet function even though it was defined as a private function. Let's look at behaviors. Many modules share the same public API. Take a look at plug, which as its description states is a specification for composable modules in web applications. Each plug is a module which has to implement at least two public functions, that is init and call. Behaviors provide a way to define a set of functions that have to be implemented by a module. Then they need to ensure that a module implements all the functions in that set. If you have to, you can think of behaviors like interfaces in object-oriented languages like Java, a set of function signatures that a module has to implement. Okay, defining behaviors. Say we want to implement a bunch of parsers, each parsing structured data, for example a JSON parser and a message pack parser. Each of these two parsers will behave the same way. Both will provide a parse function and an extension function. The parse function will return an Elixir representation of the structured data, while the extensions function will return a list of file extensions that can be used for each type of data. For example, JSON for JSON files. Let's create a parser behavior. Let's create a module for this and we need to call this dual parser do. Okay, I'm passing the documentation again, so I'm jumping to callback attribute parse string dot t resolution operator colon OK term and pipe sign. Then we have error string dot t. Then we have the documentation again. We don't need this. Just jump to the extensions function. Extensions, no parameters received. Resolution operator string, sorry, it's list string dot t, and that's it. We have defined a parser module. So if I call the parser module parser dot extensions, says function parser dot extensions is undefined. Extensions, okay, the module is undefined because we didn't define the function exactly. We just defined the callback. Modules adopting the parser behavior will have to implement all the functions defined with the callback attribute. So we just have defined the callback attributes. We haven't really defined the functions themselves. As you can see, callback expects a function name but also a function specification like the ones used with the @spec attribute we saw above. Also note that the term type is used to represent the parsed value. In Elixir, the term type is a shortcut to represent any type. Adopting a behavior is straightforward. You need to define a module and you can define a behavior, let's say call parser, and you can implement the parse function and the extensions function. So let's define the JSON parser module. Def module JSON parser do @behavior parser implementation parser, and let's define the function parse string do colon OK slash some JSON not equal to str parse JSON. Okay, now let's implement parser again. This is an example of extensions colon do JSON. Okay, let's end the module and we have the JSON parser at hand. So let's try JSON parser dot extensions, and we got the extensions JSON that we have defined. And let's call the parse function and let's pass hello. We got some JSON hello. Def module YAML parser do. Similarly, we can define a YAML parser. In this parser, we are just changing the extension to YAML, and here we are saying YAML instead of JSON. If a module adopting a given behavior doesn't implement one of the callbacks required by that behavior, a compile time warning will be generated. Furthermore, with implement IMPL, you can also make sure that you're implementing the correct callbacks from the given behavior in an explicit manner. For example, the following parser implements both parse and extensions. However, thanks to a typo, bad parser is implementing parse instead of parse. This code generates a warning letting you know that you are mistakenly implementing parse instead of parse1. because in this function we are not receiving any parameters and there is nothing to parse here, so it will generate a warning. Behaviors are frequently used with dynamic dispatching. For example, we could add a parse function to the parser module that dispatches to the given implementation and returns the OK result or raises in cases of error. So here we can do some dynamic dispatching. So let's rewrite our parser module, def module parser do, and here we can set up callback parse string.t resolution operator colon OK term pipe sign error and string.t. Similarly, callback for extensions, no parameters, resolution operator, and list string string.t. Okay, that's it. Let's define the parse not function implementation contents do case implementation dot parse contents do OK data. Okay, if data is received, we pass in the data, and if error is received, we show an error message and raise the error, that is the argument error. Raise argument error saying parsing error colon hash error. So we have the parser module rewrote again. Note that you don't need to define a behavior in order to dynamically dispatch on a module, but those features often go in hand. If you liked this video, don't forget to subscribe to my channel. If you need any help, feel free to contact me at my email address umahmood@gmail.com, my LinkedIn profile, or my Twitter handle. See you next time with a new topic in Elixir.